Hello again, Beaufort Middle School students. This is Mrs. Brigman, and today we are going to continue with our algebra unit, Moving Straight Ahead. This is lesson 4, and in lesson 4, we are going to learn how to solve for a variable, and our focus is on one-step equations. Your essential questions for this lesson are, how can I solve one-step equations? And also, how can we use variables to solve equations? Please find your guided notes and fill in this equations checklist. When you are confronted with a one-step equation, you are going to be solving for a variable, and we've already talked about a variable being an unknown quantity. This is your checklist. These are the steps that you want to take to solve one-step equations. First, identify the inverse operation. Now, the word inverse here means opposite. So, if the operation that is being done to the variable is addition, then the inverse operation would be subtraction. If the operation being performed to the variable is multiplication, then the inverse operation would be division, and vice versa for both of those. That's your first step, inverse operation. Your second step is to balance the equation. This means we want to do the same thing to both sides of the equal sign. We need to keep both sides equal. Balance the equation. Third, you're going to solve. And finally, check your answer. So the most important thing that you remember for this topic is IBS. Inverse, balance, solve. And then if you're a really smart student, you'll always go back and check your answer. All right, let's start with some examples. Please write in your guided notes exactly what I am writing so that you have the steps for solving one-step equations. Now, in this equation, we have x plus 7 equals 10. Now, what I'd like for you guys to do is draw an imaginary line down where your equal sign is. And we just do this to kind of separate our equation into two different parts, the left side and the right side. Now, we need to remember that we are going to follow the steps IBS, inverse, balance, solve. Now, it's very important that you always start on the side with the variable. Remember, in one-step equations, you are trying to solve for this x. You are trying to solve for this variable. So your eye should go straight to the variable. You need to start on the side where the variable is located. And in this case, it's on the left side. So we're going to start over here with the x plus 7. Now, our first step is I, which stands for inverse operation. So in your head, you need to ask yourself, what operation are they performing to this variable? They are adding 7. So what's the inverse of addition? What's the inverse of adding 7? Yes, subtracting 7. It's the opposite operation. So that takes care of our first step. Now our second step is to balance the equation. So whatever you do to one side, you have to do the same exact thing to the other side. We are keeping our equation equal on both sides by doing the same thing to both sides. You always have to do the same thing to both sides. This is keeping your equation balanced. Your third step is to solve. So starting over here, if we have a positive 7 and a negative 7, what does that equal? Yes, it equals 0. Over on the right side, you would just do 10 minus 7, which equals 3. Now, your equal sign comes down, your x comes down, your plus can come down, and x plus 0 is just x. So x equals 3. In fact, since positive 7 and negative 7 equals 0, you can just cross through these And you really don't even need the 0 there. You can just bring the x down. So x equals 3. Now, our final and fourth and final step in solving one-step equations is to check your answer. So what you can do is plug this answer into your original equation. So originally we had x plus 7 equals 10. Now, in our answer, we got x equals 3. So if we plug in the 3 into the equation, we can see that 3 plus 7 does equal 10. So we know we have the right answer. All right, let's try another example. Again, I want you guys to draw the imaginary line straight through the equal sign. Now, over to the side, you can write IBS, just to help you remember inverse balance solve. Now, your eye should directly go to the side that has the variable, and in this case, it's the right side. The y is on the right side, and we are trying to solve for y, so we need to start on this side. Always start on the side with a variable. Then ask yourself, what are they doing to that variable? They are subtracting 12. So the inverse, or the opposite operation, would be to add 12. That's our inverse operation. And now we're going to balance. Whatever you do to one side, you have to make sure to do it to the other side so that everything stays equal. And finally, we're going to solve. Now, on the right side, we have a negative 12 and a positive 12, and that is equivalent to 0. So you can just cross through these because they equal 0. Just shoot through them, just like that, strike through them. The y is going to come down. Your equals will come down, and now you need to solve negative 9 plus 12. You are adding integers, so if you have to, come to the side and show your work. Negative 9 plus 12, the signs are different, so we're going to find the difference, which is 3, and keep the bigger sign, keep the positive. So your answer is 3. Y is equal to 3. Now, again, you can always go back and check your work and make sure you have the right answer. There's no reason why you should ever get these wrong because you can go back and plug that 3 into the original equation. So let's do that now. We have negative 9 equals, and our y was equivalent to 3. So I'm going to plug in a 3 right where the y's position was located, minus 12. And now let's solve this side just to make sure it equals negative 9. We learned never to subtract. You add the opposite, and 3 plus negative 12 is negative 9. So we know we got the right answer. Always go back and check your work. All right, let's try example 3. This is solving a multiplication equation. So again, start with drawing your line straight through the equal sign. And of course, when you become a master at one-step equations, you no longer need to draw this line, but we're going to keep it here just to help keep our work organized. Now, which side do you think that you need to start on? If you said the left side, then you are correct. You always start on the side that has the variable because that's what we're trying to solve for. So we're going to start on the left side. Now, we're going to perform IBS, inverse balance solve. So ask yourself, what operation is going on here? Well, this is actually negative 3 times x. Remember, it's understood that there is a multiplication symbol here. If you ever have a constant, a number, right next to a variable, it is understood that you are multiplying those two numbers. So you need to perform the inverse operation. So the opposite operation of multiplication is division. Now, I want you to get in the habit of writing your division symbols with the fraction bar. So our inverse of multiplying times negative 3 would be to divide by negative 3. Please notice I did not change the sign. I did not do the opposite sign. I did the opposite operation. The opposite of multiplying is dividing. Please start writing your division symbols like this, like a fraction. So again, the inverse of multiplying times negative 3 is dividing by negative 3. Okay, now we're going to balance. So we're going to do the same thing to the right side. And finally, we're going to solve. Now, over here on the left side, you have -3 divided by -3, which is really equivalent to 1. So you can actually cancel these two numbers out. The -3 and the -3 cancel. And what you're left with is x. The reason that that works is because -3 divided by -3 equals +1. And so this is really like a 1x, but we drop the 1 and leave the x. Your equals will come down, and then you have 45 divided by -3. 45 divided by -3. Remember your dividing rules for integers. A positive divided by a negative equals a negative, and then 45 divided by 3 equals 15. So x equals -15. Okay, what was that last step? You can always go back and check your work. So let's try it. Our original equation was -3, and then for the x value, I'll put parentheses and place our -15 because that's the answer we got. And we're going to see if it actually comes out to be 45. Well, a negative times a negative is a positive, so that's good. And 3 times 15 is 45. So we know that this is the correct answer. All right, example 4, let's try solving a division equation. So again, I'm going to start by drawing my line straight through the equal sign. And now which side do you think we need to start on? Okay, if you said the left side, you are correct because that is where your variable is located. It's very important that you always start on the side with the variable. Now, we're going to perform IBS. But first, we need to figure out what operation is this. We have learned from our prior lessons that this fraction bar is really division. It means divided by. This is x divided by 2. So we have x divided by 2 equals 75 hundredths. What is the inverse operation of dividing by 2? Yes, multiplying by 2. So the way I would like for you guys to show your work is to draw a little dot for multiplication because we're doing the opposite of division, which is multiplying. And we're going to write 2 over 1. Since this is sort of in a fraction form, we want this to look like a fraction. So you just put the 2 over a 1. 2 divided by 1 is equivalent to 2. So you can write it like this. So again, the inverse of dividing by 2 is multiplying by 2. Now we're going to keep our equation balanced, so since we multiplied by 2 on this side, we need to multiply by 2 on the right side as well. So that takes care of our first two steps, and finally we're going to solve. Now when solving, the 2's cancel because 2 goes into 2 once and 2 goes into 2 once. So you can actually cancel out the 2's and you're left with an x equals, and then we'll solve 0.75 times 2. And so you'll have to come to the side to show your work for that. Don't forget to count out your decimal places. And so the answer is 1.5. All right, example number 5. This is solving an equation using a reciprocal. So let's try this one. Go ahead and start by drawing your line straight through the equal sign. And what side do you think that we need to start on? If you said the right side, you are correct because that's where your variable is located. Now, in this case, you have 2/3 times x times x. So the inverse operation of multiplication would be division. So you technically, since they multiply by 2/3, you want to divide by 2/3 because that would be the inverse operation. Well, dividing fractions is basically just multiplying by the reciprocal. So if you see a fraction right next to a variable, you can cancel it by multiplying by the reciprocal. So let's try it. And I'm just going to rewrite the problem. We have 2/3 times x equals -4. All right, we're going to multiply by the reciprocal. So I'm going to put a little dot here for multiplying. Now, the reciprocal is just flipping the fraction. So let's flip the fraction. It's going to be 3/2. Multiplying by the reciprocal of this fraction. All right, that's the first step. The second step would be to balance. So since we're multiplying by 3/2 on the right side, we need to multiply by 3/2 on the left side as well. And since this is a fraction, I'm just going to put a 1 underneath the 4, the -4, to make it a fraction as well. Okay, on my right side, you know, multiplying with fractions, you can cross cancel here and everything's going to cancel out because 3 goes into 3 once, 3 goes into 3 once, and 2 goes into 2 once, and 2 goes into 2 once. So you have, this is equivalent to 1 whole. So technically on the right side you have 1 times x, but of course we want to just drop the 1 and get in the habit of just writing x. It is understood that there's a 1 there. Your equals comes down, and then we need to solve this left side. All right, 3 times -4 is -12. Remember, a positive times a negative is a negative. And then 2 times 1 is 2. We're not finished yet because this can be simplified. This is -12 divided by 2. If you want to rewrite it over to the side, you can. -12 divided by 2. A negative divided by a positive is a negative, and 12 divided by 2 is 6. So x equals -6. Again, you can always go back and check your answer, so let's try it. We're going to do 2/3 times x, which was -6, and let's just see if we get -4 as our answer. 2 times -6 is -12, and 3 times 1 is 3, and this would be -12 divided by 3, which equals -4. So did we get the right answer? Yes. You can always check your work. All right, for example 6, we are going to use what you learned in the last lesson, and this is combining like terms. Sometimes you'll have to solve a one-step equation where you first have to combine any terms that are alike, just like this example. So let's start by drawing our line. Now, your eye should directly go to which side? Which side do you think you need to start on? If you said the right side, then you are correct. We're going to start over here on the right side and try to solve for A. Now, in this case, you have 3 terms, and if that's the case, you want to ask yourself, is there anything I can combine? Are there any terms that are alike? In this case, the 1.3 and the 4 are both like terms because they're both constants. They're both regular numbers. So we're going to combine them. And remember, when you're combining like terms, you are taking the terms and adding them together. Combining means to add. So over to the side, I'm going to add 1.3 plus 4. And remember, this is 4, which is equivalent to 4.0. So you want to line up your decimals when you're adding with decimals. And so this would give us 5.3. So now we can rewrite this equation as 5.3, and then we've got plus A. The equals comes down, and your 2 will come down as well. All right, again, we're going to start on the right side because that's where our variable is, and you want to ask yourself, what is the inverse operation? Now, you have a positive 5.3, so now to get rid of this positive 5.3, to move it, to cancel it out, you have to do the opposite. So it's a positive, and the opposite of a positive is a negative. So we're actually going to subtract 5.3 because then we'll be able to cancel it. Let's keep everything balanced by subtracting 5.3 on this side. And now, if you have opposites, if you have a positive and a negative, the same number, you know that's equivalent to 0, so you can cancel this out, straight through it. All right, this A comes down. And now we have 2 minus 5.3, and I want to rewrite this just so it makes a little bit more sense over here to the left. So 2 minus 5.3. Okay, if you think back to our last unit, you have to remember your subtracting integer rules. And we learned you never subtract, you add the opposite. So I'm going to draw these lines to keep my work organized. Keep the first number the same, change subtraction to addition, and then the opposite of 5.3 is negative 5.3. We added the opposite. All right, 2 plus negative 5.3 is equivalent to negative 3.3. And if you're wondering how I got that, I basically just found the difference between the numbers. I did 5.3 minus 2.0. I found that the difference was 3.3, and keep the bigger sign. So you've got to keep that negative. So A is equal to negative 3.3. Again, plug this value into your original equation and check it and make sure it equals 2. I can do that by adding 1.3 plus negative 3.3 plus 4, and that will give me 2. All right, let's try a word problem. Now, what I'm going to do is, as I read this word problem, I am going to circle the numbers and underline the hint words. So again, I'm going to circle the numbers and underline the hint words. It says the Apollo 11 mission lasted about 195 hours. The flight from Earth to the moon lasted about 103 hours, and the flight from the moon back to the Earth lasted about 71 hours. About how many hours, that's what we're looking for, about how many hours did the Apollo 11 astronauts spend on the moon? So if we talk this problem through, we can kind of write it out in words. The entire Apollo mission is going to equal the time it took to fly from Earth plus the time the astronauts spent on the moon plus the time it takes to come back to Earth from the moon. So this kind of puts your word problem into an equation using words. So now let's fill in our numbers. The Apollo mission lasted 195.5 hours. The time from Earth was 103. Time on the moon, this is our unknown quantity. The question said, how many hours did we spend on the moon? So this is unknown. We do not know what it is. So I'm going to use a T because the T will represent the time on the moon. And then our time from the moon was 71 hours. And now we're going to solve. I'm going to start by drawing my line. I'm going to start on the side with the variable and ask myself, is there anything I can combine? And yes, you can combine your constants. You can combine a 103 and a positive 71, which is going to give you 174. So we have 174 plus t equals 195.5. Starting on the side with the variable, we're going to do the inverse operation, so we're going to subtract 174.0, so your decimals line up. And then on your right side, you can cancel. You're left with T equals 195.5 minus 174, which equals 21.5. So T equals 21.5 hours. The astronauts spent 21.5 hours on the moon. And you could check your work by adding the time it took them to come from Earth plus the time on the moon, which is the answer we got, plus the time it took them to come back to Earth from the moon, and see if it adds up to 195.5. And if it does, you know you have the right answer. All right, last question. This is example 8, flying disc. You throw a flying disc to your dog. It stays in the air for 2.5 seconds before your dog catches it 30 feet away from you. What we're going to do is write and solve a multiplication equation to find the speed of the disc. Now we're going to use this formula that they gave us, and this formula stands for distance equals rate times time. And the question asks us to find the speed. The speed is the rate. Those are synonyms. Speed is the rate. Now, let's plug in the things that we know from our equation. We know that the disk was in the air for 2.5 seconds. So here where the time is, seconds is a time measurement, so we're going to put 2.5 right where the T, where the time would be located. We know our dog caught it 30 feet away, and feet is a distance measurement, so we're going to plug in 30 here. The question asks us to find the speed, so the rate is what we're looking for. That is our unknown quantity, so that's going to stay R. So our equation is 30 equals 2.5 times R. Remember, I moved the constant in front of the variable because you always want your constant term to be in front of the variable. Numbers come first and then variables. All right, let's solve. Draw your line. This is a multiplication problem. On the right side, they are multiplying times 2.5. So we need to remember I, B, S. The inverse of multiplying would be to divide. All right, balance. So I divided both sides by 2.5, and now I'm going to solve. 2.5 divided by 2.5 is equivalent to 1, so you can cancel these numbers. Strike through them. The R is going to come down, the equals will come down, and now you're going to have to compute 30 divided by 2.5, which that will give you 12. So your rate is 12 feet per second. That is your final answer. And if you were to plug in 12 right here for the R, for the speed, you would see that 12 times 2.5 does indeed give you 30. So this is the correct answer. All right, for these one-step equations, I would like for you to get a blank sheet of paper, and you are going to copy these questions, draw your line, your invisible line, through the equal sign, start on the side with the variable, and please remember your steps. I, B, S. Inverse, balance, solve, and then always check your work. I would like for you to try these 6 problems and then press pause, try these 6 problems on a scratch sheet of paper, which will be checked tomorrow in class, and then press play on your video screen again because I am going to provide you with the answers to these 6 questions. I just want you to try them and then check your work and see if you got them correct. If you do not get them correct, go back and see if you can find your mistake and make the correction. All right, press pause now and complete these 6 questions. All right, guys, I hope you didn't find that too difficult. I'm going to now give you the answers to these unknown quantities, these variables, and please check your work. For number 1, you should have gotten t equals 7. For number 2, you should have gotten n equals negative 6. For number 3, you should get m equals 14. For number 4, you should have gotten r equals 24. For number 5, p equals 3.4. And for number 6, s equals 4.7. Those are all your answers, so hopefully you got most of them correct. If you did not get them correct, go back and try to find your mistake. All right, y'all, here are your turn questions for this lesson. Please complete all of these questions on a separate sheet of paper. You can complete them on the same sheet that you just completed 1 through 6 on, and your teacher will check these tomorrow. Thanks. Have a good night.